Suppose you're asked that, given an array, find the maximum sum of a contiguous subarray. Now, contiguous means, if I can write it out here, is not skipping over any elements of that array. Just to visualize this, if we have an array, let's say 1, 0, 3, 4, -1, okay, let's define this because we'll have to use it anyway. This would not be a subarray because we're skipping over the one in the middle here, right? Not all the elements are adjacent. We're just picking out of the array. Now what would be contiguous is, say, 3, 4, -1, because all of the elements are adjacent in the original array. We're not skipping over everything. It's all good. So knowing that, how do we solve this? Now what I'm going to introduce is what's called the Kadane's algorithm. So given an array, instead of just iterating over all the possible subarrays and comparing all the sums possible, in which case would be double counting, triple counting, counting backwards. It'll be slow, it'll be messy. Don't do that. Instead, use the Kadane's algorithm, where we carry forward useful information. Now, what is that information in our case? We use two things. We keep track of our current sum, which would just be, I guess a good way of saying it is the max sum of a subarray ending at the current index. So while iterating over our array, is keeping track of different subarrays and what that sum is. And I'll show you how we use this. And we keep track of our max sum, because right, obviously we'll have to return a max sum, so somehow we need to find this. And let's actually initialize these variables, as the first index of our array. And we can't just choose 0, because what happens if our array is all negative? Our max sum can't be positive if all of these elements are negative. That'd make no sense. So that's why we start at index 0 instead, especially because we're iterating over. In our case, we'll use a for loop, or a range loop, because we're going over index rather. That'll make things easier. In range. And let's start at 1, because we already defined our sums as index 0, so we don't need to iterate over 0. Length of our array. And now we get to why this algorithm is so powerful. So our current sum becomes the max of whichever number we're iterating over. And what the current sum is plus the number we're iterating over. And so what this basically tells us is, should we continue this subarray or restart, right? If let's say on a first iteration we have 1, then obviously it's just 1. On our next iteration, it's still 1, or both are equal. But on the third iteration, then this becomes bigger, so it chooses the max of this and it continues the subarray, right, until 3. And so it updates our current sum. And how we use that is we use our second piece of useful information or useful variable, and we update our maxsum to just be max of the maxsum or the current sum. And intuitively, say we have our subarray here that I was talking about. So we found 1, 0, 3. Okay. It's saying, yeah, we should continue the subarray because the sum is growing or is equal, right? And so it updates our max sum to be that sum. However, if the subarray becomes smaller, right? Let's say we get to the end here and we get to our -1, then it doesn't update to this, it updates to whatever that is, right? Or it only counts this subarray. And so our max sum stays this. So now to test our function and troubleshoot it if I coded anything wrong, or max sum, let's define, let's call upon our function. So I believe it's always good to define a variable to call upon a function or to print it rather than just printing the function itself. And if we call upon it, then we cannot access local variable I where it's not assorted. Yes, of course, because we're not iterating over it yet. So let's do index 0. And now we get 8. And we can see that that is true. This is our subarray. 1 plus 3 plus 4 is 8. Our functions didn't count this, didn't count the -1, because our subarray would have been smaller, right? So it didn't update the max sum to be that. And so let's test some edge cases. So let's say we have all negative numbers. I don't know. Maybe that'll mess things up. It's always good to test these things. -1, that makes sense. This is our small subarray of 1. Say we have some really big number. Let's have two really big numbers of different signs. Still works. And so I'm pretty satisfied with our results. So let's clean up, space out our code, act us out to get rid of these notes at least. And there we go. That's Kadane's algorithm.